Hi, also just going to pick up from where we just left off. So we were left talking about pattern completion, which is the process by which once one neuron within a chain of neurons is activated, and these are all neurons that have been wired together. So some cue from the environment triggers a specific neuron, for example, one in the prefrontal cortex, and that neuron is connected to other neurons that form some representation of a memory, for example. This is going to cause all of those neurons to be activated together. So this is pattern completion. So to really understand this, let's walk through a visual example of this. Now, the theory under which we're operating here is referred to as multiple trace theory. And multiple trace theory assumes that information about a memory is stored in multiple locations in the brain. And in this example, this illustration, we'll just look at this first panel here, is information about a particular event is stored in both the neocortex, this could be your prefrontal cortex, so newer, more advanced structures of the brain, and are related to neurons in the hippocampus. So the hippocampus is where initial learning of an event occurred. This is where long-term potentiation happened. And what happens is, let's say in this panel here, these two neurons represent one episode, maybe what happened last Saturday. And you encounter something familiar. So let's say last week you saw an old man in a park. Well, now you see that old man again, and this might activate this particular neuron. Maybe information about having seen this old man before is stored in this neuron. Well, this neuron is connected to a neuron in the hippocampus where initial learning occurred. And this neuron, upon being activated, should also go out and try to reactivate the other neurons that form the full representation. So in this case, it should go and reach this neuron as well. However, it might also reach out to other neurons that share a relationship with it because the hippocampus has a relatively more limited amount of room to store bits or pieces of episodes in mind. And so there has to be some mechanism to separate this event from this event when both events are sharing some overlapping representation. And so some mechanism is needed to choose the correct representation, that is to activate the correct or desired representation from long-term memory. And this process would be pattern separation. So pattern separation is the process of isolating the desired neural pattern underlying a learned experience. And this is in contrast to pattern completion. So let's just illustrate this a little bit here. So what's going on in this figure? Here, let these cells represent, let this slice represent cells in the neocortex. And this represents a cell in the hippocampus. So there are multiple neurons here that represent, say, a past experience. And the activation of one of these neurons activates the another neuron that is stored in the hippocampus. So this is like a relay back to what other projections did that hippocampal cell make. And so it could be projecting back to each of the other neurons too. And so in this particular example, in A, the hippocampal neuron is connected to 6 neurons in the neocortex, but none of these neurons in the neocortex are connected to each other. Their only connection to each other occurs through this hippocampal cell. Now, some of these do pertain to the same event. So for example, in B, these two neurons, which are a subset of the neurons in A, so it's this neuron and this neuron, pertain to a particular event. And if we want to isolate event B, we don't want for the hippocampus to be signaling other neurons that are part of different events. So you can see this here in pattern separation below. There are 2 events here, one represented by the red neurons and one by the green neurons. But there are some shared overlap. So for example, neuron C in the neocortex connects to the hippocampal cell that also connects to A and B, and it also connects to a hippocampal cell that connects to D, E, and F. So neuron C in the neocortex is shared between two different events. And so the activation of one of these neurons, say A or B, will activate this hippocampal cell. And this hippocampal cell is also going to activate neurons that are storing part of a different event. And pattern separation is necessary to ensure that the event that is retrieved is the ABC event and not the CDEF event. So a little bit of a complex theory here, but the basic idea here that underlies this theory is long-term memory formation occurs initially in the hippocampus. Neurons are strengthened together through long-term potentiation. This causes not only for hippocampal neurons to be strengthened, but for projection from the hippocampus to other regions of the brain, the neocortex, or what's often like the prefrontal cortex, to also be strengthened. Then, upon encountering some cue in the environment, one of those neurons is activated. And the whole process of retrieving the full episode requires that the connection between the neurons in the neocortex and those in the hippocampus be fully reactivated, but be separated from shared or similar overlapping representations. So to summarize long-term memory, the storage of information or memories that occurs across the lifespan, whereas working memory, which we discussed earlier, is limited in its capacity, long-term memory is presumed to be unlimited in its capacity. Learning in long-term memory occurs via neuronal communication, a process we discussed that was called long-term potentiation, which is basically the strengthening of neuronal connections in the hippocampus and later between hippocampal neurons and neurons in other parts of the brain. So over time, these connections pass to the neocortex, that can be the prefrontal cortex. And when an episode is retrieved, pattern completion enables all the neurons that make up the representation to fire together, whereas pattern separation ensures that neurons that overlap with other representations are not activated.